Good evening, students. So, in the class 11, we are studying chapter number 3, that is periodic classification and periodic trends. In the last lecture, I have explained about the classification of element according to the SPDF, S block, P block, D block, and F block. Now, today, I will discuss about the periodic trend. That's mean the some property and how they vary when we move in the periodic table from one side to another side or from top to bottom. So first property, that is valence electron. Valence electron. What is the meaning of valence electron? Valence electron means number of electrons in the last shell, or you can say number of electrons in the outermost shell. So the number of electrons in the outermost shell. Suppose if you take any periodic elements like sodium, I am taking sodium atomic number is 11. If you write the configuration, you will write according to the Niels Bohr 281. This is the last shell and you are seeing there are only one electron here. So valence electrons are 1. Now see another one, second element of this period, that is magnesium. It's have atomic number 12 and its configuration will be 2, 8, 2. So how many valence electron? You are seeing there are 2 valence electron. Now moving towards the third element, Al, that is 13. So configuration will be 2, 8, 3 and valence electrons are 3. Now number next, that is silicon, atomic number 14, 2, 8, 4, that is 4. P means 15, 2, 8, 5, that is 5 valence electron. If you will write the electronic configuration, you will see that the number of valence electron, that's mean these are the valence electron. But you are seeing here 1, then 2, then 3, 4, 5, after 6 and 7, you will get properly increase in the valence electron when you are going from left to right. Suppose you are going in the periodic table from left to right in any place, you will see the number of valence electron will be in increasing order. So you can say on moving from left to right, valence electron increases one by one. But dear student, when we will see this on top to bottom side, suppose this is the element sodium and I am writing the element below sodium, that will be potassium. Potassium has the electronic configuration 19, 2, 8, 1. So valence electron will be 1 here. This is the valence electron. So what you are seeing here 1 valence electron, here also 1 valence electron. You should not satisfy by only this one example. I am giving one more example. Above sodium, this is lithium. Lithium has electronic configuration 3, that means 2, 1. And it also have the 1 valence electron. What you are seeing here, it is very clear that when you are moving from top to bottom, so valence electrons remains the same. It is not only in this group. When you will moving from this group, or any other group in the periodic table, the number of valence electron will be remains the same. Okay, students, so see what we can say on moving from left to right like this. Valence electron increases. Valence electron increases. while on moving from top to bottom, like this, top to bottom, valence electron will remain same. Dear student, you should keep in your mind, because it is the main concept of all the trends which you are going to study. But dear student, if you are going to the group 18 elements, at last what you will see, 2, 8, 8 or 2, 8 are at the first it is 2. Helium's configuration is 2 and argon's configuration is 2, 8, 2. So what you are seeing, you should not tell these are the valence electron. This is complete shell, so this is not valence electron. Okay students. Now moving towards the second property, which is directly depend upon the valence electron, that is the atomic size. Atomic size, or you can say atomic radii, atomic radius. First of all, I want to tell what is the meaning of the atomic radius. This is the nucleus. It carries the positive charge. Electrons move around the nucleus in a circular path like this. In the second chapter, atomic structure, you have studied about the calculation of atomic radii, and according to the formula, Rn is equals to 0.529 n square angstrom. By this formula, you can calculate the radius of any atom. But how the radius of atom vary? Because in the period you will be having two shells. All the elements of second period will have two shells. All the elements of third period will have three shells. So what does it mean if you will put here 2? So answer will be 0.529 into 4. That's mean all the elements of second period will have the same radius? Answer is no. So how the radius will vary? Dear student, you must know the electron around the nucleus have a range, and this distance, that's mean the distance between the nucleus and the last electron moving around the circular path, it will be called radius of atom. What happened in the radius when we moving from left to right in the periodic table? So first of all, you have to write the definition of the atomic radius and the formula of the radius of any shell. How the radius vary? See, it depends upon only the valence electron. Suppose sodium atom has one valence electron. It contains 11 proton inside. 11 proton carry 11 positive charge. So this electron will be attracted by the nucleus. Attraction force will take place between nucleus and electron. When you are going to the magnesium atom contains two valence electrons. So there are two side attraction, this side and this side. That's mean these two electrons are attracted by the nucleus. So little bit squeeze in the size of sodium than magnesium. Magnesium will be little smaller than sodium because number of valence electron increases and force of attraction between nucleus and valence electron increases. If you are seeing the aluminium has 3 valence electron. So what will happen? Now it is clear that 3 types of attraction force will be here. That's mean nucleus attract the electron from 3 directions, so more attraction force will take place and size of the aluminium will be smaller than magnesium as well as sodium. As well as you are moving from left to right, number of valence electrons increases. If the number of valence electron increases, so more attraction will take place and the size of the atom continuously decrease. But dear student, this size will decrease from group 1 to group 17. It will not be considered in group 18. As I have told, when you are seeing the valence electron in group 18 that is called noble gas, that means it has 2, 2, 8, 2, 8, 8 like this. So these 8, this 8 or this 2 are not considered as a valence electron because shell is completed. So complete shell will not be considered that a valence electron. Valence electron, we can say the electrons in the last shell that can take part in the chemical combination. But these electrons cannot take part in the chemical combination. That's why these electrons are not considered. That means size of the atom on moving from left to right continuously decreases, but up to 17 group. Up going to the 17 to 18 group, size will little increase because atom will be stable. Now moving the trends of downside. If you will see from top to bottom, in magnesium, first is beryllium. Beryllium atomic number 4, it is a group 2 elements. Its configuration is 2, 2. It contains 2 valence electrons. While magnesium, it is atomic number 12 and configuration is 2, 8, 2. It also has 2 electrons. After that, calcium, it has 20 atomic number 2, 8, 8, 2. So you are seeing these all are having the same valence electron. So what will be happen if the size of the atom will be same? No. Dear student, you are seeing there are 2 shells here, shell number 1, shell number 2. And here there are 3 shells, shell number 2, shell number 1, 2 and 3. And in the calcium, you are seeing 4 shells, 1, 2, 3, 4. And below calcium, that is strontium 38, will have 5 shells. Similarly, when you will move from top to bottom, you will see the number of shells are increasing. So number of shells are increasing, so according to this formula, size of the atom will increase. So what you have concluded on moving from left to right, atomic radii decreases, and on moving from top to bottom, atomic radii increases. So it is clear, I think. But now moving towards the Ionic Radii, it is also a very important, that is atomic radii. Ionic radii. First of all, you must know what is the meaning of ion. Suppose you are taking aluminium, Al. Al is equal to 13. It contains 2, 8, 3. There are 3 valence electrons. Aluminium 13, this is a neutral atom. When it loses electron, 1, 2 or 3, so it will form Al triple positive in case of losing 3 electrons. So configuration will be 2, 8. This is aluminium, 13 positive charge in the nucleus and 8 electrons in the last shell. 8 electrons in the last shell, that means Al triple positive, 2, 8 configuration. When it will be Al, it will have 2, 8, 3. That means 13 positive charge and 13 negative charge. But here what you are seeing, 13 positive charge and 10 negative charge. So 13 positive will attract more 10 positive. That means last shell contain 8 electrons which will be attracted by the 13 positive charge, so more attraction will take place and the size of the cation will decrease. As the nuclear charge increases in the cation, this is called cation, after losing the electrons, size will decreases. Sodium positive is always less than sodium. Magnesium double positive is less than magnesium. Why it is? Because sodium positive contain 10 electron, 11 proton, and more attraction because of more nuclear charge. That means 11 proton will attract, see like this, 11 proton attract 10 electrons. Similarly here, magnesium double positive contain 10 electrons and 12 proton. That means 12 proton attract 10 electron, so size will be more smaller. So in cation, size will decrease. All the cations are generally smaller than their respective parent's neutral atom. Sodium positive is smaller than sodium. Magnesium double positive is smaller than magnesium. Similarly, Al triple positive is smaller than Al. But in case of anion that means when the electrons come and form a negative ions. So, suppose I am taking chlorine. Chlorine has 17 electrons and chloride, that means Cl negative, has 18 electrons. In this case, electrons are 17, protons are 17. In this case, electrons are 18 and protons are still 17. So 17 proton attract 18 electrons. That means less attraction takes place. So size of the ions will little increase. That means always negative ion, that will be called cation, is greater than their parent atom. O double negative is greater than O. F negative is greater than F. So I think students, you have got everything about these three properties: atomic radii, ionic radii, and valence electron. So dear student, now you have to write some question. You have to these question and send me in my comment section as well as in the WhatsApp. Question number 1. What are valence electron in group 14 elements? Group 14 elements. Question number 2. Arrange B, C, N, B, E, L, I according to size. You can say atomic radii. Question number 3. Arrange following ions according to ionic radii. Ca double positive, Mg double positive, K positive. So these questions you have to do and solve. Send to my WhatsApp number. Next day we will meet again. Thank you. Good night.